We are T-minus 9 minutes and counting. Ground launch sequencer now controlling. All countdown events are now being controlled by the ground launch sequencer until T-minus 31 seconds, when the countdown will be handed off to Columbia's onboard computers. Ground launch sequencer relays commands to the onboard computers, which then report back that the commands have been received and executed. The primary job of the onboard computers, which is called the Redundant Set Launch Sequencer, or RSLS, is to check that all Space Shuttle launch vehicle criteria are met.
NTD, we're waiting for man recorder activation. Coming. ELT, Go ahead, sir. Configure fuel cell essential bus source switches. Roger, connect essential buses to fuel cell. Flight NTD, proceed with transmission of stored program commands.
Flight Wilco.
Standing by now for the ground launch sequencer to retract the orbiter crew access arm from the vehicle and into the launch configuration. This occurs at T-minus 7.5 minutes and about 15 seconds. In an emergency, the arm can be re-extended in just 15 seconds if that's necessary. Standing by now for orbiter access arm retract.
Genesis go for orbiter access arm retract.
Arm now being retracted. T-minus 7 minutes and counting.
NTD, P30. Go ahead. Yes, sir. Astro 1 and BBXRT are powered down and ready for launch. Copy. Understand.
Word that the broadband X-ray telescope is ready.
NTD ISL. Go ahead, ISL. Okay, recorder's activated. Okay, copy.
In about 20 seconds, the orbiter test conductor will give pilot Guy Gardner a go to perform the auxiliary power unit pre-start procedure. Gardner will then be setting switches in the cockpit to put the APUs in the ready-to-start configuration.
Recorder running.
Hydraulic strip chart recorders now running. T-minus 6 minutes and counting.
OTC, PLT. Perform APU pre-start. APU pre-start and work.
Five minutes, 40 seconds and counting.
OTC, PLT, APU pre-start complete, 3 grade talkbacks. Copy.
Gardner reporting the APU pre-start is complete. The APU activation comes at T-minus 5 minutes. The APUs provide the hydraulic power to the orbiter. All data recorders are running. T-minus 5 and counting.
ELT, OTC. Go ahead, sir. Perform APU start. APU start and work. CDR, OTC. CDR, go. Reconfigure heaters. And work.
Commander Vance Brand has been asked to reconfigure the orbiter heaters for launch. He will report when that's complete. We're now verifying that the range safety safe and arm devices are on. And this will be followed by arming the boosters for launch.
APU start complete. Copy. And CDR heaters reconfigured. Copy that.
APUs up and running. Heater configuration complete. Report that we have 3 good APUs. test of the orbiter's flight controls is about to start. The aerosurfaces will be moved, the rudder, the elevons, and the speed brake. That will be followed by gimbaling the main engines. T-minus 3 minutes, 40 seconds and counting. Rudder being moved through its positions. Standing by now to gimbal the main engines. All systems are go for launch at this time. Main engine gimbal profile complete. Standing by for retraction of gaseous oxygen vent hood. The ground launch sequencer will make a final check. Pressurizing the hydrogen tank now.
PLT, OTC, clear caution warning memory, verify no unexpected errors.
OTC, PLT, clear caution warning memory.
Fuel cell systems now transferring to internal power. Standing by now, the retraction of the gaseous oxygen vent hood is underway. The ground launch sequencer will confirm when it is fully retracted.
Clear, complete.
Copy.
Liquid oxygen tank now at flight pressure.
And flight crew OTC, close and lock your visors, initiate O2 flow. Have a great flight.
Gillis is go for ET, LH2 pressurization.
Pressurizing the liquid hydrogen tank, T-minus
CDR,
1 minute, 45 seconds.
Visors down, and we'll see you later. Thanks a lot.
Copy that.
Commander reporting visors are down. T-minus 90 seconds. At T-minus 31 seconds, the ground launch sequencer will hand off to Columbia's onboard computers. Waiting confirmation that the hydrogen tank is at flight pressure. Confirmation the hydrogen tank is at flight pressure. T-minus 1 minute and counting. Ground launch sequencer verifying main engines are ready for ignition. Hydrogen burn igniters are armed. Sound suppression water system armed. Heaters on the joints of the solid rocket boosters have been turned off. T-minus 40 seconds. Flight data recorders are on. Coming up on a go from the ground launch sequencer. T-minus 31, we have a go.
Gillis is go for auto sequence start.
Handoff has now occurred from the ground launch sequencer to the space shuttle. Columbia's computers now controlling.
20.
Booster hydraulic power units have started. T-minus 16 seconds. Sound suppression water system is armed. 12, 11, 10.
Gillis is go for main engine
Go
start.
for main engine start. 7, 6, 5, 4, 3 good engines up and burning. 2, 1, 0, and liftoff. Liftoff of the Space Shuttle Columbia and Astro 1 for an insight into the lifestyle of the galaxies.
Roll program.
Roger, roll, Columbia.
This is Mission Control Houston now controlling as Columbia ascends through 1,400 feet. Good roll confirmed here on the ground. 3 good main engines, 3 good auxiliary power units, and 3 good fuel cells. Columbia now at 6,100 feet. Three main engines are now throttling down to ease Columbia's passage through the period of maximum dynamic pressure on the vehicle. Now at 18,000 feet. Relative velocity now 1,100 feet per second. Three main engines now throttling back up, and we show them now at 104%.
Columbia, go at throttle up.
Roger, go at throttle up.
Go at throttle up, and now Columbia at 67,000 feet, downrange 8 nautical miles, relative velocity 2,500 feet per second. Now passing through 100,000 feet, downrange 16 nautical miles, now relative velocity 3,600 feet per second. Standing by for SRB SEP call. And good SRB separation confirmed here in the control center. Three engines at 104%. Columbia now passing through 200,000 feet, downrange 46 nautical miles.
Columbia, performance nominal.
Roger, Mike, performance nominal.
Columbia, two-engine banjul.
Two-engine banjul.
Columbia's first stage performance nominal. They've also just been told they've got sufficient velocity to make the transatlantic landing site in Banjul, the Gambia, should one engine fail. Currently at 252,000 feet, downrange 70 nautical miles now, relative velocity 5,400 feet per second. Still showing three main engines at 104%, three good auxiliary power units, and three good fuel cells providing about 7.5 kilowatts each, and Columbia now at 275,000 feet, downrange 90 nautical miles. The ECOM officer here in Mission Control reports good cooling on the flash evaporator system that provides cooling uphill. Columbia now at 305,000 feet, downrange 115 nautical miles, relative velocity 6,700 feet per second.
Return.
Roger, negative return.
That call indicates Columbia now passed the margin at which it could make a return to landing site abort. All systems performing well aboard the vehicle. No systems problems to report whatever. We're still showing 104% throttle.